The next part of our study we want to look at is we want to start to look at thin lenses. When we did reflection, we looked at mirrors. We went through mirrors using the ray diagrams and then the mathematics. Well, with refraction, we're going to do the same thing. The big thing that we want to examine are the thin lenses, and we're going to do that in one of two ways. We're going to do it graphically with the ray diagrams, and then we're going to do it mathematically with the equations. Now, you'll see the word thin lenses. The reason we're assuming thin lenses is we only want to assume that the light, when it enters the lens, it only refracts once. This simplifies our math and our geometry a little bit. Whereas in reality, if light enters a lens, when it first enters the lens, it's going to refract. And then when it exits the lens, it's going to refract again, and it's going to create this lateral shift. We don't want to deal with that in high school, and we're not going to do that. So this is our main thing, is we are dealing with thin lenses. So the two types of lenses that you'll see, you're going to see first of all this thing called a converging lens. You may see the term convex lens, but we will use convex strictly for mirrors and lenses. We'll use convex for mirrors, not lenses. So we're going to talk about a converging lens. So in a converging lens, what's going to happen is the light rays are going to come in parallel to the lens, and then they are going to refract such that they converge on this focal point. And then, of course, we have our focal length. With lenses, the focal length is going to be that distance between the center of the lens and the focal point. The other type of lens that we can look at is this thing called the diverging lens. So for the diverging lens, what's going to happen is your rays are going to come in parallel to your principal axis, and then when they pass through the lens, they're going to diverge and they're going to spread away. But they're going to spread away such that if we extended those rays back, they're going to look like they originate from some virtual focal point. So diverging lenses, you may also see the term concave lens. Again, though, we're going to use convex and concave for mirrors. We're going to use converging and diverging for lenses. Now, before we get into the technical stuff with lenses, I just want to kind of talk about some real-world applications. For those of you that wear glasses or contact lenses, you are wearing lenses. Now, we're simplifying the explanation a little bit, but just to kind of give you an overview of that. So when some of you get your prescription for your lenses, like depending whether you have nearsightedness or farsightedness, your optometrist or ophthalmologist, they might give you a number saying like, yeah, your prescription's +4 or it's -3.5. So those numbers, they're actually referred to as the diopter. And the diopter is actually the inverse of the focal length of your lens. Specifically, it's in units of in units of inverse meters, because it's assuming that your focal length of your lens is actually given in meters. So those numbers actually do have value. And just on that topic of nearsighted and farsightedness, just to kind of, give you a little bit of the physics behind what your lenses are doing. Again, I need to emphasize that this is an oversimplification, so we're just kind of doing this more of a broad strokes thing. So nearsightedness, if you want to get technical, it's called myopia. So myopia or nearsightedness, it's a condition where things far away are not very clear. So you can see very well close up. Far away, you have a little bit of a problem. So what's actually happening for a person who has nearsightedness is that the focused image that's formed with the convergence of those light rays, that focused image is happening in front of the retina. This is causing the light to be blurry. So what's happening in your lens is the light is refracting a little bit too much. So what somebody with nearsightedness is going to have is they're going to have some type of diverging lens. So what's going to happen is that when the light rays come in, they're going to be spread out. So then when they spread out and then hit the lens of your eyes, they're going to start to be refracted or converging, and then they'll converge on your retina. Or the idea is to have your prescription such that the focused image converges on your retina so that you can see things clearly. So what's happening right now, or for without glasses, is the light rays are bending too quickly. So what we want to do for a nearsighted person is we want to take their lens, we want to make it a diverging lens. We want to spread those light rays out a little bit first, and then have them converge such that, again, that focused image happens on the retina. So for somebody who has farsightedness, which is not as common, especially in younger people, also referred to as hyperopia, basically what's happening in this case is things far away, not a problem. You can see them fine, but images close up, they're a little bit difficult to detect. So what's happening in this case for somebody with farsightedness, the focused image is occurring behind the retina. So again, it's not being seen clearly by the person. So what's happening for this person is their lens, it's not bending the light enough. It's not bending it enough so that the image forms on the retina. So what somebody with farsightedness is going to have is they're going to have a converging lens instead. Because what the converging lens is going to do is it's going to bend that light a little bit already. It's going to bend it towards the focal point or the retina. And then the lens of the eye is going to bend it even more, such that by the time it gets to the retina, you're going to have a focused image there. So each type of eye condition is going to require a different type of lens. Now, like I said, these are simplifications, because then you're going to have people who have like a combination of lenses and all that. But like I said, this is just to kind of give you an overview of how we use lenses in the real world.